Good morning, one and all honors physics students, and welcome to another edition of Physics, the honors edition. Hope everybody had a great spring break. It's Mr. Finn, of course, coming to you recorded and after our spring break this Monday. So hopefully everyone's doing great out there, staying safe, staying healthy. A couple of things to start our day today. Number one, the over-under on the COVID-19 survey. Obviously, the overs have it since we are canceled for the year until further notice. So what does this mean? I got a lot of questions on grades through email. I'm still waiting for some direction from our administration, but as of this morning, I plan to keep grading on Classroom, Google Classroom. And then what I'm going to do is if we're going to just merge those grades with MyStar to the best that we can, or I can migrate them over, piecemeal. But we got to figure out how we're going to merge the Google Classroom grades, the stuff you've been doing online, with the stuff that you did for the first 8 to 9 weeks of the semester. So no worries, I'll get on that as soon as I get some better direction from the administration on what we're doing for the rest of the year. Okay, so what does this mean for us today and going forward this week? We're going to be starting a new unit. This unit will be on electrostatics and electric fields. So keep on track of the Google Doc and the related reading and questions, and we'll go from there. But the question today starts with, how does a charged balloon stick to a wall? Why does that happen? A lot of people know that if you charge a balloon and stick it up to a wall, it'll stay there. But relatively few people know exactly how that occurs. Maybe we should demonstrate this first and see what's going on. Okay guys, so here's what I have. I have my balloon. I stuck it to a wall. I'm going to pull it off the wall and reattach it. But I used this fur from, I don't know if it's an old rabbit or whatever. But I rubbed this fur on the balloon, and then I let the balloon stick to the wall. I rubbed the balloon with the fur, stuck it to the wall. So let's take it off there for a second. You can actually see there's fur all over the balloon. Let's try it again, just so you can see what's going on. I'm going to rub this side of the balloon with the fur. And I placed the part that was rubbed with the balloon, or with the fur, right onto the wall. And the balloon sticks to the wall. Now, how does this happen? See, it doesn't have very long. It's not a great day for it. If this was actually the best day for this, we would be having a winter day in the middle of a cold spell with no moisture. Okay, let's talk about how this is going on. We'll visit the magic board for a minute. Okay guys, welcome back. So, what I have here is I have a picture of my balloon on the wall. And I've drawn in on the balloon some excess negative charge. Now, how did that charge get on the balloon? Well, we rubbed two surfaces together. Actually, I rubbed some fur onto the rubber balloon. And so what happens is friction, a force that we know well, does some work to rip electrons off of one object and deposit them onto another. Now, why would that happen? Well, if we remember back to chemistry, there are some things about the atom and the way the electrons are attached to the atom that explain some of the reasons why that happens. For example, electronegativity, maybe ionization energy. If I rub my hands together, that doesn't create a charged hand, this one positive and this one negative. My skin is the same on both sides. I would need two objects that are not the same. And those objects would have either a propensity to lose electrons from its exterior or in addition to, an object that has a propensity to gain electrons on its exterior. So, the hair or the fur has a tendency to lose electrons on its edges. And the rubber, an insulator, has a chance or propensity to gain electrons on its exterior. So friction is a way of charging an object. Now, if we look at this balloon here, I've drawn some excess negative charge on the right side of the balloon. Now I've also drawn a couple of positive and negative charges in the rest of the balloon. We have to understand there's billions and billions of charges inside or on the surface of a balloon. We don't need to draw all of those charges. That would take a long time. We just need to draw the excess or representation of some excess. So what I've drawn here is some positives and negatives, representing that obviously the balloon would have protons and electrons of equal quantity if it were just sitting around on the floor. But as I rub it, the balloon acquires a negative charge in a certain area. We're going to come back to that concept later this week. But the negative charges now are facing the wall. So what happens in that wall? Why don't we have a little think about that? Okay, guys, did you have to think about that? Let's talk about that wall. Now there's charges in the wall of all kinds, but there's equal number of positives and negatives in the wall. What I hear a lot from students in the beginning part of the section is they think that the balloon is somehow negative and that the ground or the wall is somehow positive. But the wall is not positive. The wall is actually polarizing. What is polarization? Well, that's when local charges start to separate within a neutral molecule. So a molecule is actually neutral, but there are parts of the molecule that look positive or negative if you were to approach it from that side. A good example of this is a water molecule. Water molecule has 2 hydrogens and 1 oxygen. And the oxygen has most of the electrons. You guys may remember this from chemistry. So if you approach the water molecule from the side containing the 2 hydrogens, you'd see a lot of positive charge. If you were a microscopic little creature and you approached it from the opposite side, from the oxygen side, you might see a whole lot of electrons around that oxygen in a partial negative charge. Because, again, your electrons reside mostly towards the oxygen atom. So this can happen for other materials as well. Local charges within a neutral molecule separate or align themselves to show a certain amount of charge. So if I look up at the wall here, my negatives that were on the wall randomly, negative, positive, negative, positive, positive, negative, positive, negative, well, the negatives migrate inward into the wall. So they may have been here and they move to there. Just to the other side of some atom, maybe just out of the way, to show the negative of the balloon a more positive charge. You kind of have a line of positive charge on the wall, and you have a row of negative charge on the balloon where we deposited it. So the attraction or electrostatic interaction between the negatives of the balloon and the positives of the wall, well, that's why the balloon can stick to the wall. Remember, we had a couple things today. Friction, the way we created charge on the balloon, and of course, the big lesson of the day, polarization. Polarization, the local charges within a neutral molecule separating and showing some electrostatic interaction as a result of that. You guys okay with that? All right, let's wrap up today. Okay, guys, so welcome back from break, obviously, and let's talk about the recap of today. Number 1, we can use friction, a force that we learned in the first semester, to create electric charge or an imbalance of charge. Now remember, we didn't actually create that out of nothing. We just took electrons from one object and deposited them onto another object. So the total amount of charge is not changed just by moving electrons from one to another. That's actually called the conservation of charge. And we'll come back to that one as well, but it follows the conservation of energy. We're not actually creating any new charge. We're just moving electrons from one place to another, and we're using friction to do it. So friction is our first way of creating charge on an object. Well, secondly, the lesson of the day on polarization. The items can switch around their charges spontaneously so that they can electrostatically interact with a charged object. So to recap, like charges, well, they would repel each other. So if you had two negative charges, they would try to move away from each other. Opposite charges, like a negative and a positive, well, they would attract each other. But what happens when you have a charged object and a neutral object? Well, that is going to depend on the material that we're dealing with. It's a lot easier to put a balloon on a wood wall than it is on a metal wall, because a metal operates a little bit differently than a piece of wood or a wood cabinet. These are some of the things that we're going to talk about as the week goes on. But just to get you guys started and get into the reading, I'm going to start with polarization and friction to create charge. One other thing, guys, since we're not coming back to school on a regular basis, we are going to try to use a Google form each week to kind of figure out where you stand in terms of the week's material. Remember, we don't have school on Friday because it's a religious holiday. So we're going to go Monday through Thursday of this week, and the Google form will be available for you on Thursday. Remember, I'm keeping track of all those grades, and I'll just merge them in as soon as I get some clear direction from our administrative people. Thanks for tuning in, guys, and we'll see you tomorrow.